Hello, everyone. Hello. Hey, that woke everyone up. How was your lunch? Did everyone get lunch, hopefully? I'm not sure, how many people were in the session I did previously, the last session in this room? Okay. So I apologize to all of you already, but to those of you who weren't in the last session, I just want to throw out another apologies for the fact that people are having to sit on the floor, cramming at the back, etc. Clearly, we didn't get the scaling right on this one. So apologies, I'm sorry, but thank you very much for coming and listening today. So for those of you that weren't in the last session as well, my name's Paul Maddox. I'm a specialist solutions architect at AWS. I focus heavily on containers in my day-to-day job and work with companies of all sizes to help them with things like containers and serverless and just generally improving their development experience on AWS. So for the next hour or so, we're going to be talking about Kubernetes. Can I get a show of hands who's running Kubernetes today? Keep your hand up if you're running it in production. Keep your hand up if you're running it really well in production and are completely happy and everything's happy and shiny. Okay, less hands. Hopefully by the end of this talk, I'm going to show you a way that you can run Kubernetes in a much, much more confidence-inspiring way on AWS. So, what to expect from this session? We're going to dive deep into Kubernetes on AWS. We're mainly going to focus on our upcoming EKS service. So there was a whole ton of speculation before reInvent time at the end of last year around, hey, AWS, is AWS going to do a managed Kubernetes service? Are they not? And there was a lot of, speculation in the media. It's so nice that I can actually talk about this in public now. We announced at reInvent that we are doing a Kubernetes service, EKS, our managed Kubernetes offering. So we're going to be focusing on that today mainly, rather than actually best practices for running it yourself on AWS. We'll touch on that a tiny bit, but the majority of this is going to be a chance for you to see and get hands-on with the EKS service that we currently have in preview. So just really quickly before we dive in, on the topic of that preview, I know there's a lot of people in this room that probably don't have access to the EKS service yet. You don't need to show your hands. I get the message. Everyone wants to get their hands on and try it. So at the moment, it is in a limited preview. The limited preview is only in one region in the US. It's not for production workloads, and its primary purpose is for us to gather feedback from customers and existing Kubernetes users on, are we building the right thing? Are we adding all the features that customers want? It's not a place for you to go and run production workloads, even though it's in beta, etc. So we are still taking people on into the beta. Every month, we're adding more and more customers into that beta. The best way to get access is sign up on the public webpage. There's a webpage where you can register your interest. That does go somewhere, I promise. It's not just throwing it into a black hole that no one ever reads. So the best way is to do that. If you have an account team, like a solutions architect and account manager in AWS, speak to them as well. They may be able to help. But ultimately, it is quite a slow rollout there. And we'll talk more about that as we go through. So I'm going to talk through why manage Kubernetes. Hopefully that's fairly self-explanatory. I'm not going to spend much time on that. Then we're going to talk very briefly about what good Kubernetes on AWS in a self-managed form looks like today, how most customers are running it themselves, and kind of some of the methods of doing that. And then we're going to dive into actually what is EKS. So for those of you that don't have access and haven't seen it hands-on, I'm going to deploy some clusters, and we're going to get hands-on, we're going to play with it. I'm also going to walk you through exactly how it works under the hood. Right, it's a managed service. What are the trade-offs with a managed service? Normally, there's trade-offs between convenience and visibility. So I'm going to talk you through, and hopefully by the end of this session, you have a really good understanding of what EKS is going to provide and what it's going to solve for you. Finally, we're going to talk a bit about the future of EKS as we see it in Kubernetes on AWS. So why EKS? For a long time now, customers have run Kubernetes on AWS. The CNCF, Cloud Native Computing Foundation, did a survey a while back that showed that actually the majority of Kubernetes installations today run on AWS. And currently to date, this is something that customers are doing themselves, right? Managing, running, operating, deploying, etc. All these kind of challenges are customers' problems at the moment. And if you've worked with AWS for a while, you'll see a pattern. when we see customers reinventing the wheel, going over the same undifferentiated heavy lifting over and over again, typically that's something that we want to help customers with and offer a managed service in that space. And that's a very repeated pattern within AWS. So we knew a large percentage of our customers were running Kubernetes today. We heard loud and clear that actually it wasn't ideal. So if you look at the common methods for deploying Kubernetes today, there's a couple out there. One of the more popular ones is KOPS or KOPS, depending on how you want to pronounce it. And this is a CLI tool that builds out a cluster, a Kubernetes cluster, a highly resilient, highly available Kubernetes cluster on AWS. It solves a few of the pain points around upgrading your cluster and managing your cluster. So it automates things like version upgrades of Kubernetes. You can just change in a manifest file version 1.8, version 1.9, and it's going to do a rolling update of all of your minions and worker nodes for you and your masters, etc. So it goes a long way towards making something that's self-managed actually workable for a lot of people. When you dive into it a bit more, KOPS is doing quite a bit under the hood. Right, to just get a cluster deployed, you need to get the CLI tools installed, obviously, with like AWS CLI and stuff. You've got to configure the IAM roles. You need to create an S3 bucket for KOPS to store its state in, like the state of what your cluster looks like. It keeps that in an S3 bucket so it's resiliently stored. You need to set up things like Route 53 zones for your cluster, or use a gossip-based protocol cluster. So there's not many steps. KOPS is still a really, really good way of deploying things. Like no issue if that's what you're doing. If you're happy doing that, keep doing it. But there was some general feedback we got loud and clear from our customer base. Amazon, please carry the pager for us. Like, we don't want this operational overhead, the engineering overhead of running, scaling, managing, operating, monitoring, backing up, blah, 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 Kubernetes. And that's where EKS really comes in. So I mentioned we announced this at reInvent. It's in preview. We'll be rolling it out later this year. There are a couple of key tenets that we had to keep in mind, or we wanted to keep in mind, while designing this service for our customers. And I'll run through them now. Number one, it needs to be production grade. We want customers, and we have some of the biggest customers in the world using AWS, and people like Ticketmaster and Zalando run Kubernetes on AWS, people like Monzo. We want to be able to offer them a production-grade experience that scales to what they need. And we want to do that for all of our customers. So what do we mean by this, really? We want to take away the pain of backing up, monitoring, replication, things like high availability across multiple availability zones, therefore data centers. And we want to do that for you. And I'm going to dive into exactly how that works under the hood as we progress through this today. Ultimately, though, production-grade workloads. The next one, and if you're in Abby's State of the Union this morning, she alluded to this as well. The next one is a really common question I got while we were still talking about this previously is, Amazon, please, for the love of God, do not give us an Amazon-specific version of Kubernetes that only works on Amazon and locks us into Amazon. Right? Categorically, that's not our goal here. We want to provide a native and upstream open source experience. The Kubernetes that's running in EKS is going to be open source Kubernetes. It's not an Amazon-specific fork. If you want to take things out of EKS and move them into a self-managed Kubernetes environment, you should have the freedom and the options available to you to do that. So that's the core tenet that we've worked towards. And part of this, right, there are areas that we want to improve in Kubernetes. There are areas that we think could actually work better in terms of integrating with AWS. So wherever we're making those improvements and committing back, we're actually going to be open sourcing those, upstreaming those back into the Kubernetes upstream version or into open source plugins, etc. So that even stuff that we build to make EKS and Kubernetes better, you can still use those plugins, use those open source toolings, etc. in self-managed Kubernetes infrastructure that you run. So the next tenet was around AWS services and the integrations. So ECS, if you were in my ECS talk earlier, there are a whole load of integration points with ECS. Things like CloudWatch logs integrated out of the box with ECS. Things like load balancers like the ALB and ELB, NLB, etc. There's tight integrations, things like IAM roles. A lot of these areas with Kubernetes you can do today yourself, but it's heavy lifting. There's a lot of open source community-driven plugins to do this kind of stuff, but it's heavy lifting often. This is an area that we want to improve and make Kubernetes run really, really well on AWS. So we're going to be going over a few of these and providing a bit more concrete details of what I mean there as part of this presentation. Fourth one is the reason we joined the Cloud Native Computing Foundation, the CNCF, is because we want to be able to actively contribute back to Kubernetes and actually back to the wider CNCF projects. So CNCF has, I don't know, 14 or so main open source projects that it supports today. Things like Linkerd, things like Containerd. These are areas that we will also be investing time and Amazon engineering effort into feeding back to open source. Okay, let's get into the tech a bit more. Let's look at a typical Kubernetes architecture. So at the top here, you've got your master nodes. If you've been watching the Kubernetes issue tracker, these might not be called master nodes for much longer. That's up for debate at the moment. So the master nodes at the top, these are where your Kubernetes pods actually run, right, in terms of the scheduler, the API, etc. So these are the nodes that actually schedule your containers onto your worker nodes at the bottom. To do that in these, yes? Yeah, so the question was, how many availability zones will you need for EKS? So the recommended best practice there is going to be 3 because you need a quorum for etcd in most cases. There are some workarounds that we've seen people do to run it on 2 AZs. General best practices would be 3 AZ cluster there. So I can't categorically say it will only be available in 3 AZ regions at launch. I don't have the information there. It's still in beta. We're still deciding a lot of this stuff. Certainly the recommendation would be 3 AZs, so you get the quorum there and avoid split brain. So you have your master nodes. They're scheduling the pods onto your worker nodes at the bottom, and Kubernetes keeps its state in etcd. So what's EKS providing here? Essentially, we're doing this. The worker nodes at the bottom, where your containers actually run, are going to remain your responsibility. To deploy them, to build them, to run them, these are just EC2 nodes. They're running in your AWS account, and we're going to make it as easy as possible for you to deploy these, but ultimately similar to ECS without Fargate today. These are EC2 instances that run in your account. The managed service is the master nodes in etcd. So this is the bit in the AWS cloud here. So we're going to be running the master nodes in etcd for you in a highly resilient, available fashion. And we're going to be exposing the Kubernetes API endpoint. It's just the standard Kubernetes API endpoint, which means that you can use your existing tooling like kubectl and CI/CD plugins and Helm, etc. We're just exposing the API endpoint for you. EKS is a deliberately simple and boring service. Boring is good in this context. Okay? So EKS has 4 API calls today. It's like a simple CRUD API. Create a cluster, describe, delete, and list your clusters. Really, really simple API. We've done this deliberately because we actually want to get out of your way as soon as possible so that the majority of your configuration activities are going to be done in the Kubernetes APIs, not the AWS-specific APIs. So using things like RBAC for role-based access control in Kubernetes, network policies, etc. So we're going to cover that in more detail, etc. But the general key theme here is you get your cluster deployed, and we get out of the way, and you continue working in Kubernetes in the way that you currently do if you run Kubernetes today. So let's talk a little bit about how EKS is actually architected, some of the technical details of what's happening behind the scenes here. Let's start with the master nodes. So the master nodes we're going to be running in an auto-scaling group for you. They're not going to appear in your EC2 console. This is a managed service, so much like RDS, for example. These are instances that are going to be deployed outside of your EC2 console. That make sense? So we're going to be deploying an auto-scaling group for you of master and etcd nodes. etcd is going to be encrypted at rest. The master nodes and etcd are going to scale up and down automatically. So as you add more and more workers, as you schedule more and more tasks, those master nodes are going to automatically scale in and out depending on your requirements. So if you look in the Kubernetes documentation today, there's pretty clear guidelines based on how many workers, et cetera, that you're running and how many masters and what size masters that the configuration should look like. So we're going to be following those guidelines and scaling on your behalf the masters and etcd nodes so that you don't need to worry about that. The masters are going to be running in active mode across the availability zones. So if there was an availability zone failure, or if one of the master nodes died for whatever reason, then the other two in the other availability zones are going to be there. They're going to carry on working. You shouldn't see any interruption. But the auto-scaling group is going to automatically bring back that master for you in the missing AZ. So just like normal auto-scaling there, but taken care of for you, scaled automatically. You don't need to worry too much about that. The other bit about the master nodes is kind of tied to the Kubernetes version. So another common question I get is, which version of Kubernetes am I getting? Have I got any control over that? And the answer there is that we're going to be supporting sort of the main version, the current version, and a couple of versions back. So when you deploy a cluster, you'll see this as we get hands-on in a minute, you pick your version of Kubernetes that you want to run. So in the beta, in the preview that's available at the moment, that's 1.7, but when it goes GA, it will be much more recent versions. It's just what we're using in the beta and preview. So you're going to pick your version. From then on, any minor version updates to Kubernetes, like if you look at the Semver version numbers, the minor updates, they're going to be applied automatically for you to your cluster. So things like bug fixes, security fixes, etc., they're going to be applied automatically. Yeah?
For the worker nodes as well, or just for the master?
No, just for the master and etcd nodes there. So the worker nodes, I'll cover like a strategy for patching those in a minute. So for the master nodes, your Kubernetes version is going to be, the minor updates are going to be applied automatically. Customers generally want more control over the major version updates, so like 1.7 to 1.8, 1.9, etc. So we're going to offer the ability to do automated updates there, but also you'll have the ability to pin that version and keep it at a specific version, right? If you know, for example, that your application has some compatibility problems with the latest version of Kubernetes, like there's a bug or something, then you should be able to have control over that. The only thing we're going to do there is we're only going to support a couple of versions back. So if you pin your cluster to a particular version and don't upgrade it, don't allow automatic updates, etc., eventually there will become a point in time when the version you are running is going out of support on Amazon EKS. When that happens, you're going to get a notification, right? Similar to when EC2 needs maintenance or something. You're going to get a notification that says, hey, you've got X amount of days to upgrade this yourself, otherwise we're going to forcefully do it for you. We'll do it in a zero downtime fashion, right? We can upgrade one master at a time, etc. But part of the managed service offering here is only supporting a couple of versions back. So with a managed service comes questions around visibility normally. So it's a trade-off. I'm getting, this Kubernetes master is managed for me. What am I giving up in terms of visibility, and what can I do, what can't I do? Let's dive into that a bit. So the master nodes and etcd nodes, you're not going to be able to SSH into them. They do not appear as EC2 instances in your AWS console. These are part of the managed offering. So in terms of visibility, we're going to be exposing a couple of things from the masters for you. So with CloudWatch logs, you're going to get the logs from the kube system pods that run on and containers that run on the master nodes. So you're going to get centralized logging out of the box for all of the kube system stuff. You're going to get metrics in CloudWatch, so graphs and metrics on the performance of your cluster. But you're not going to be able to SSH into those masters. So the next question here that often rapidly follows that up is, but Amazon, I run a load of stuff on my masters today as add-ons. So maybe you run Prometheus, for example, for monitoring purposes. And maybe you're running some sort of other add-ons. I can't speak for when this service goes generally available, because it's still in a state of flux. We're still responding to that customer feedback, etc. But certainly in the preview, there isn't an ability to add add-ons onto your masters. Therefore, if you've got stuff that normally runs on your masters today, you'll need to run those containers on your worker nodes. We are looking into ways of adding add-ons as like a managed option. So you could tick a box and say, yeah, I want Prometheus installed as an add-on on my cluster, but that's something that's still being decided on and worked out. I would say if you've got any strong feelings about the kind of add-ons you want to see built in there, raise that with Abby or myself. Come tell us, like the team is actively looking for feedback at the moment as to which add-ons we might want to include in that managed offering. So hit us on Twitter or come find us afterwards and let us know. So in the architecture diagram earlier, and to answer your question, how do the worker nodes work here? So these are just EC2 nodes. You manage them, you deploy them, etc. in your AWS account. But we're going to be doing a few things to try and make that as easy as possible for you. So the first is that we're going to publish an AMI. This AMI is going to be a Kubernetes optimized AMI. So very similar to the ECS optimized AMI that we published today. There's going to be an SNS topic that you can subscribe to and get notifications of any changes to that AMI so that you can automate its rollout within your infrastructure. This AMI is going to have like Kubernetes installed, ready to connect up to EKS, all the best practices, etc. built in there. We're going to be very transparent with how we build this AMI. So we're going to use Packer and publish the Packer scripts used to build this AMI. So there's nothing stopping you creating your own. You can just take what we've done, take those Packer scripts, add in your own customizations and security. Hell, if you want to just completely ignore our AMI and use your own, you can do that. Right, there's flexibility here, just like with ECS. So on top of this, we're going to be publishing some CloudFormation templates as well. So when you sign up to the EKS beta or preview today, if you get given access to it, you get given 2 CloudFormation templates. One of them creates like the base VPC and stuff that's needed by EKS. The other one is a CloudFormation template that spins up worker nodes. So you can use this CloudFormation template, and before someone asks the question, if you're using Terraform, Ansible, insert other configuration management tool here, you can continue to do that. You don't have to use our CloudFormation templates. You can just take what we've put in CloudFormation and put it in your own Terraform scripts or whatever. Like, we're not locking you into CloudFormation in any way here. So let's touch a little bit on networking configuration and how this is going to work for EKS. So before I go on there, when you look at networking in Kubernetes today, in general, Kubernetes works in a very modular, plug-in fashioned way of networking. So when I bring up a pod in Kubernetes, Kubernetes is going to go to your network plugin of choice, like Calico or Flannel, for example, and it's going to run that plugin, and it's going to say, hey, I need an IP address for this pod. Please assign one. So there's a whole load of plugins out there today, like Calico, like Flannel, etc., that try and solve this problem. They all have pros and cons and trade-offs. So Calico, for example, they came out of trying to simplify container networking. They had a really, really good vision of how good container networking would look. So every pod gets its own IP address in a Calico network. One of the downsides is that between availability zones or between subnets, there's encapsulation required. So there's like encapsulation tunneling, etc. You've also got this Calico network, and then you've got a different network that your Kubernetes hosts run on, right? The VPC network, where your ETH0 is homed. And so if you want to do any diagnostics or translation to the outside world, you need to hop through this network and trace the packets through those different networks. So it's really good. Calico is a great way of doing networking. But for AWS, we thought there's a better way of doing it. So we released a CNI plugin, open source CNI plugin on GitHub for Amazon VPC networking on Kubernetes. And this has some really nice benefits that I'm going to call out and go through and give you an idea how it works. Essentially, what it does is every single pod gets a native VPC IP address. So no overhead of overlay networks, no extra complexity of hopping through different networks, just every pod gets a native VPC IP address. Yes?
It supports IPv6 as well.
So the question was, does it support IPv6? No, I don't believe so at the moment, but it's open source and we welcome pull requests. That's good feedback, though, seriously. I'll take that away. So if we look at how this works in a bit more detail, we've got a couple of instances here running in a VPC, so within a single region. And we got a couple of pods. When these pods get scheduled, the CNI plugin is going to get run by Kubernetes. The CNI plugin is going to go away to the EC2 networking backplane at the top here. And it's going to say, hey, I've got a new pod. Can you give me an IP address for it? The EC2 backplane is going to go back to CNI with an IP address. And essentially, the ENIs that you have on your Kubernetes hosts are going to get mapped through. They're going to get secondary IP addresses, loads of secondary IP addresses on each ENI. And they're going to get mapped through to the individual pods. So this means if this Rails pod over here on 10.0.0.2 wants to talk to this one on 10.0.0.22, it can just directly communicate with that IP address. No NATing, no routing, no overlay, no tunneling, etc., no encapsulation. Really, really simple, really, really performant. One of the more interesting things here is around how security groups work. So obviously on a cluster, you probably want you want to have some level of network isolation for your containers and pods. You want to be able to say, this pod should never ever talk to that pod, etc. AWS security groups are done at an ENI level, not at a secondary IP address level. So what this means is the recommended approach with EKS is going to be to have security groups that allow all communication between all worker nodes between your Kubernetes hosts. So how do you get this network level isolation then? So we've been working heavily with Tigera. Tigera are the creators of Project Calico. One of the cool bits of technology that came out of Tigera is network policies. So they're a Kubernetes primitive that allow you to define which element, so either a namespace or a pod or an application selector, etc., can talk to other things within your Kubernetes cluster. So this is going to be the recommended approach for network isolation within your Kubernetes cluster. What's really nice about this is it's not AWS specific. So it's very, very portable. If you define your application traffic flows and rules in a network policy, you can use that same network policy when you're on-prem or whether you're on another cloud provider or whatever. So you're not dealing with AWS specifics here. It's the Kubernetes abstractions that you're working with. I put a link at the bottom there to this Amit B's GitHub repo. This is just one I found recently. It was a really useful one for me. It shows a load of example recipes of network policies. So, okay, I want to allow this namespace egress to this one on this port, etc. And it does them all with nice visualizations and animations. So if you need to go and create a network policy, there's a whole load of really useful pre-canned recipes there. You can probably just copy and paste. Next, IAM Authentication. So back to the point I made earlier about integrations with the AWS platform. There's a couple of ways people are using IAM today for security within Kubernetes on AWS. So the first one is, how do I assign IAM roles to my Kubernetes pods? How do I give them permission to do stuff in AWS securely? So there's an open source project that's by far the majority project that I've seen out there at the moment, Kube2IAM. We're going to be investing in Kube2IAM and actually committing back to Kube2IAM to make some improvements to it. So Kube2IAM is going to be the recommended go-to approach for assigning IAM roles to pods. But there's another side of IAM authentication as well that we think we can improve for our Kubernetes customers. So when you provision a developer or someone who wants to access or use your Kubernetes cluster, you normally give them a config file, normally. And that config file contains a key or token or some sort of authentication parameter, which means it's a dedicated config file per user of your cluster, right? It's what configures kubectl, for example. And that's an extra step in provisioning that isn't really necessary. If the laptop or machine or EC2 instance that needs to access Kubernetes already has AWS credentials, right? If it's my developer laptop and I've got AWS creds, why can't I just use them for authentication? Then we get the nice benefit that everyone in my organization, their config file for kubectl could be identical, right? That you haven't got to provision individual users. So that's the approach we've been taking. We've integrated IAM directly into kubectl, the CLI command. So we've been working with a company called Hepps IAM on this, and it's completely open source as well. Again, this is not tied to EKS. You can use this today on your ECS clusters, on your Kubernetes clusters, self-managed ones, much the same as the network plugin as well, the CNI plugin. So the way this works today is it's a patched binary of kubectl. It's not ideal. It hasn't been upstreamed back into main upstream kubectl yet. That's absolutely the route we're taking. But right now today, if you join the Kubernetes EKS preview, it is a patched binary that we distribute. We know that's not ideal. That will be changing. So when you run this kubectl binary, it passes your local AWS identity into Kubernetes, which will go away and identify and authenticate the user. And it will say, yes, IAM says this person is who they say they are. The next thing you need to do is authorization. So I know this person's who they say they are. What should they be able to do in my cluster? Right? Do I want them to deploy to development namespace only, but never to production, et cetera? So for that authorization, you're going to be using RBAC. So Kubernetes has built-in role-based access control, much like it has for network policies. For network isolation, you get RBAC for role-based access control. So you can define RBAC policies that say, okay, this IAM role maps through to my developer profile, for example, and they can do this, 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 and this. So you can play with this today. It's available on GitHub, and I thought I'd put the link on there, but if you just search for it in Hepps IAM, you'll find it, and you can play with that today. So looking out to the future and where we see EKS going. I mean, first, we're going to launch it. But after that, what next? So Fargate is the obvious choice here. A lot of this that we've been through today involves you having to deploy those worker nodes, configure, manage them. Yeah, we give you the building blocks, the CloudFormation templates, et cetera, to do that. But you shouldn't need to do that, ideally. We believe that the future of containers is containers as a primitive. Being able to give AWS your pod definition, we run it for you without you having to think about infrastructure, patching, monitoring, maintaining, that kind of stuff. So we are working hard on EKS on Fargate for EKS. That will be coming. I can't give any hard timelines at the moment, though, but we're working hard on it. So I think a couple more and then we'll do a demo. Okay, so one really, really useful resource that I wanted to call out is some work that our Kubernetes and open source teams at AWS have been doing recently on an open source workshop, learning-based, hands-on learning workshop. So this is on GitHub. You can go here and there's a whole load of workshop modules ranging from beginner level, so deploying your first cluster with KOps. As soon as we have EKS out there, we'll be adding EKS into there as well as an option. Right through to the more advanced stuff like how to work with stateful sets, ingress controllers, service mesh integration using Linkerd and its.io, et cetera. So this is a really useful resource. Like if you've got engineers or developers starting at your organization and you just want to skill them up in a self-learning environment on Kubernetes on AWS, or if you yourself just want to get more hands-on and play with some of this stuff, recommend checking that out. Again, we're going to share the slides as well. So I'm going to give a quick demo yet because I'm very conscious that everything I've just shown you is complete slideware at this point, and a lot of people in this room haven't got hands-on yet. So let's make it a bit more concrete and real. I have to give the caveat, though, that this service still is in preview. The final version may not look like this. The final version probably will have a lot more features than this. But this is where we're at today with the preview. So this is the AWS Console for EKS. You can see I've got one cluster deployed, my demo cluster. So when you join the preview today, you get given two resources. You get given a CloudFormation template that spins up the VPC and sort of surrounding ancillary architecture for Kubernetes on AWS. And you get one that spins up worker nodes. Currently today, when I create a cluster, those bits aren't automated for me currently today. So I need to spin up those CloudFormation templates in my AWS account and create that VPC and IAM roles and stuff. So if I just go into CloudFormation, open that in a new tab. So here's one I did earlier. So there's two templates that I've loaded in here that are part of the EKS documentation, one for the VPC. And if we look at the resources that this has created, You can see it's created a really simple VPC with an internet gateway, some route tables, etc., and a role. So I'm going to take the outputs of this table, so the VPC ID, and just feed them into the EKS create console, create cluster console. So I'm going to call this demo 2. The Kubernetes version, as I mentioned earlier, in the preview, we're just using 1.7. Yes, we're well aware that 1.9's out, etc. This is just in the preview version and what we're working with in the preview. We will be supporting newer versions when this goes GA, obviously. So I'm going to put in the VPC IP ID, and then I'm going to put in the on of the role, and click Create. So behind the scenes now, this is going away, and it's going to create for me that auto-scaling group of highly available etcd, Kubernetes masters, etc., and ultimately give me a Kubernetes API endpoint. So if I look at the one I created earlier, I can see here I've got a URL for my Kubernetes endpoint. If I load this up, obviously I'm not authenticated at the moment, so Kubernetes is saying, but this is just the Kubernetes API. You can interface with it with your existing tooling. And if I go to my command line, so I've got a really, really simple demo deployment here just to show you how this is going to fit together and work. So one of the problems I find with demoing EKS is there's not really much I can show in terms of a demo here. Right? This is just standard open source Kubernetes. All I can show you is a standard open source Kubernetes demo. So I've got here just a really simple service, so called Nginx, and it's of type load balancer. So this is instructing Kubernetes, please create an ELB for me. Right? Front this service with an actual load balancer in AWS. Kubernetes is going to go away and create that load balancer automatically and manage that load balancer for me. There is support coming for the NLB. I believe it's in 1.9 alpha. Actually, that's a good point. EKS at the moment is not going to be supporting alpha APIs, just to make you aware. So alpha APIs will not be part of the managed service. So I've got a service. It's a load balancer type. And then I've got a deployment. So here I'm saying I want 6 versions of this container, six containers up and running. I want to use this image, so just an arbitrary version of Nginx, port 80, and then a bit further down I've got a config map that just stores my Nginx config. So really, really simple demo of just bringing up Nginx and 6 containers and fronting it with a load balancer. So if I look in my kubectl config, this is where you'd normally have your keys or certificates to allow you to access, to authorize you with a particular cluster. This is the bit that needs to be provisioned normally on a per developer or per user basis. In this case, I've got a very standard configuration. I've pasted into the server my EKS endpoint URL. I'm specifying my cluster. And then my auth provider, this is the key bit here, is an auth provider called AWS. And this is the provider that we worked with Hepps IAM to create. And this will go away and it will take my local AWS credentials and authorize me and work out whether I am who I say I am and map that through to a role, etc. So what that means is I can then just run kubectl get.
Does it support federation logins?
I'm not sure at this time.
Or even STS?
For the Hepps IAM plugin? Yeah, I don't see why you couldn't assume a role first and use that. Have a dig into it. It's open source. They've got a really good README on the project. No one's asked that before, so I'm not 100%, but I can't see a technical reason why that wouldn't work. So I can just run kubectl now from my laptop. That's going away to IAM. It's authorizing me, and I can see, OK, I've got 3 nodes running, up and running in my cluster. I can now go and apply that config for Nginx. Apply -f Nginx. It's gone and taken that config file and deployed it into Kubernetes. So I've now got a service called Nginx, a deployment for my 6 containers, some pods, and then a config map for my Nginx config. And if I do kubectl get services -o wide, I can see, OK, my service has been created. It's got a cluster IP address, but it's also got an external load balancer that's been created for me in AWS. If I then go and look in the AWS console, EC2, I can see that my the load balancer's been created, A51, yep. And I can see that there's some instances registered. They're going to stay out of service for like a minute or so while it brings up those pods, health checks them, etc. And in a minute or two, those instances are going to go in service, and then I'll be able to hit my load balancer and see Nginx up and running. So I'll do that in a minute. It takes a minute or two just to register those, get those up online. Any questions at this point? Yes. Have we got the microphone? You don't need to stand up, but speak into the mic for the people online.
Normally on ECS, you've got your health check and an LB managing also the life cycle of your tasks. How does that work on EKS?
When you say the health check for auto-scaling, do you mean?
Also, but like also bringing them out of a cluster or bringing them in, or
so that will work exactly
restarting
as it does today in a self-managed Kubernetes cluster. Like the worker nodes, the auto-scaling group, etc. That's in your realm of responsibility with EKS. The worker nodes, like we provide the CloudFormation template to do that, but ultimately you have the freedom to configure that how you want. So, yes.
Any service discovery applied here?
So the question was any service discovery. So at the moment, it's the normal Kubernetes way of doing service discovery. So you can create a clustered IP service, and you can talk to it based on the host name. It's going to create that for you. You're going to be able to communicate with pods like that. You can run any service discovery, add-on that you want. It's.io, Linkerd, etc. You can run those. You can use those. The load balancers obviously are built in, as I showed. What above and beyond would you be looking for? How could we better integrate service discovery there?
Route 53 service discovery.
Okay.
Right now we've got managed workspaces for it, but there's no other implementations on any other AWS services, not on ECS, not on EKS. So I'm expecting to see more integration at that level where these would register on the pod itself, on the agent itself, to register against those workspaces.
Yeah, I think that's a good bit of feedback. Like recently, just before reInvent, we launched some Route 53 APIs that allow you to build service discovery on top of AWS, on top of Route 53. So DNS-based service discovery. ECS is going to be integrating that into ECS soon, so that when you bring up a service in ECS, it automatically creates like a DNS name that maps through round robins across all the containers that you have running and manages that for you. Yeah, that's absolutely something that could work better in Kubernetes today and have better integration. I'm pretty sure the team would be working on that, but I'll take that back and make sure, because there should be parity there.
So in terms of cost, will the cost be the cost of running all these EC2 instances?
The cost I don't know the cost yet, to be perfectly honest. We're not at a point in the beta or preview where the costs have been published to even internally at AWS yet. Normally that's decided later down the line. So I can't speak for the costs at this point in time. Sorry.
What are the network types available, and what are the networking limits? For instance, with AWS VPC, you've got to use ENIs.
Yep. Okay, so the question was around limitations on networking, what other networking modes are available. So the recommended approach here is going to be to use the AWS VPC CNI plugin that we mentioned with EKS. That does have a limitation around ENIs, as you called out there. So each of our instance types, sizes, families, etc., can have a certain number of ENIs attached. If you look at our documentation, there's a big table that shows all the instance sizes and families and how many ENIs they're allowed. One good thing here is because of the use of secondary IP addresses per ENI, you actually get more than one pod per ENI. So let me just bring up the documentation here. EC2. No, I've got it here. No, I'll call this out. Yeah, I know. Okay, so here's an example, right? So the top field here, you've got the maximum number of ENIs. The second field is the IP addresses per ENI. So within EKS and this CNI plugin that we're using, because it's making use of secondary IP addresses, you can actually take that first number and times it by the second number. And that's the maximum number of pods you'll be able to run on that host. So this actually works pretty well for Kubernetes in terms of sizing, et cetera, there, number of pods per host. And obviously, the larger the instance, the more pods you're going to be able to run. So it kind of scales nice and linearly there. This is actually advantageous compared to how ECS does it, where it's just using single IP address per ENI today. Abu, can you run down and... Otherwise, I've got this situation where I'm standing next to him and answering the question and then running to the front.
You can keep my laptop.
Awesome.
Whose hand was that? Oh, okay.
In the blue.
Paul's just trying to make me work today.
Yes. I'm just lazy.
One of the ways we sort of protect our Kubernetes infrastructures at the moment is by restricting access to the API endpoint, like via firewall rules or VPNs or anything like that. Do you have any flexibility to restrict access to that API on a network level?
Not at a network level today with EKS. So that endpoint is exposed to the internet. Obviously, you've got authentication, authorization there. I can't speak for the future. Like this service is still in preview. We are still constantly taking feedback from customers. What it is today may not be how it works at launch. Certainly today in the preview, that is publicly exposed. That may well change in the future. I can see that being a big ask for a lot of customers. So.
Hi again. So my question is around public networking. So let's say I don't want to assign public IPs to worker nodes, and I want to use NAT gateway for outbound traffic.
Yep.
Will this be possible in AWS?
Yes. Yeah, you'll be able to do that. There was a question at the front here in black.
That's not helpful directions.
If the customer's controlling the worker nodes, is there any plans potentially in the future for worker nodes to run outside of EC2?
Yes. So in terms of Fargate, so we will be bringing Fargate support here.
I mean, if I had data sources or something, I wanted to near the worker nodes to be near, so that was on-prem or...
But still connected into the master
but still
cluster
using
in the managed mode.
Yeah.
I'm not sure whether that's possible at this stage, to be honest with you. I can go away and check, but I don't have the answer right here and now. Yeah, sorry. No one at the back wants to ask a question and make Abby run again? No? You can just say you forgot when she gets there. It's fine.
Any questions at all?
Okay. Let's wrap it up. Thank you very much for listening to me rave on about Kubernetes for the last hour.